Hello, fourth graders. Miss Faulkner here with lesson 5. Today's lesson is pretty fun because we get to write our own word problems. And when you go and complete question 2 in your lesson 5 problem set, you are going to write your own word problem as well. We are going to be taking a look at 2 examples of how we can write a word problem based on a tape diagram. So let's take a look at our first tape diagram here. It looks like for this tape diagram, one of our values is 5 feet long, and feet measures length. So we're going to be working with something here that's measuring the length. And then our next value is twice as long as our first one. So our first one is 5 feet, and our second tape diagram is twice as long as that. And it looks like when we write our word problem, the question that we're going to be asking is solving for the total of these 2 values together. Since it tells us that the first value is 5 feet and the second tape diagram is twice as long, what will the length of the second value here be? So we know that one of our values is 5 feet, one of our values is 10 feet, and we're trying to find what they are together. So what is a word problem that could go along with this? You can pause and think of your own as well. So when we're thinking about writing a word problem, let's look at our units here. We've got feet. What could feet measure? Feet can measure the length of something, it can measure the distance of something, it can measure the height of something. So let's think about that when we create our word problem. Feet can measure the length of something. What could it measure the length of? What would be about 5 feet or 10 feet? Maybe how far we could kick a soccer ball. Let's say that one friend kicks the soccer ball 5 feet. Another friend kicks the soccer ball twice as far. How far do they kick the soccer ball all together? Here is my word problem. Chelsea and Haley are playing soccer. Chelsea kicks the soccer ball 5 feet. Haley kicks the soccer ball twice as far. How far did they kick the soccer ball all together? Does that match my tape diagram? Chelsea kicked the soccer ball 5 feet. Haley kicked the soccer ball twice as far, so the second value is twice as much as our first value. How far did they kick the ball all together? So that is the unknown that we're trying to solve for. Does that match my tape diagram? Yes. We could write a different problem though. That's the fun of lesson 5 is we get to use our imaginations. Feet can also measure the height of something. So let's say that a person is 5 feet tall. Now, I don't want to say that another person is twice as tall because people aren't usually 10 feet tall. But what could be 10 feet tall? Maybe a bear. Let's say a person is 5 feet tall and a bear is twice as tall. What are their heights combined? So here's my other word problem. A person is 5 feet tall. A bear is twice as tall. What is the total height of a bear and a person combined? Does that match my tape diagram? The person is 5 feet tall. The bear is twice as tall. What is the total height of the bear and the person combined? Now, it's a little bit silly. I'm picturing kind of a bear with a person riding on its shoulders, but hey, it matches the tape diagram, and that's the fun of this lesson is creating our own word problems. Now we want to actually solve for the unknown. So on our tape diagram here, we know that one value is 5 feet. The other value is twice as long, which is 10 feet. So we are finding the total. So 5 feet plus 10 feet, our unknown here would be 15 feet. So that would be the answer to either of my word problems. How far did they kick the soccer ball together? 15 feet. What is the total height of a bear and a person combined? 15 feet. So my unknown is 15 feet. Let's take a look at another tape diagram and write another word problem. So this one I see is in gallons and quarts, and I know that gallons and quarts measure the volume of liquids. So I'm going to be talking about a liquid here with my tape diagram. And what values do we already know? Well, we know that our first value is 6 gallons. It looks like our second value here is 3 times that. And it looks like our third value is 6 gallons plus an additional 2 quarts. And what are we trying to find? We're trying to find the total of all 3 of these values altogether. So what would this second value be? Well, it would be our 6 gallons times 3. So we have 6 gallons times 3, so it looks like our second value here would be 18 gallons. When we write our word problem, what might we be measuring in gallons? What about gallons of fruit punch at a party? Let's say that the 3rd, 4th, and 5th grade classes are having parties. The 3rd grade class has 6 gallons of fruit punch. The 4th grade class has 3 times as many gallons as the 3rd grade class. And the 5th grade class has 2 quarts more than the 3rd grade class. Here is my word problem. The 3rd, 4th, and 5th grade classes at Seven Oaks are having parties. The 3rd grade class has 6 gallons of fruit punch. So on my tape diagram here, the 3rd grade class has 6 gallons of fruit punch. The 4th grade class has 3 times as much fruit punch as the 3rd grade class. So my tape diagram for 4th grade, this value here is 3 times as much as the tape diagram for 3rd grade. The 5th grade class has 2 quarts more fruit punch than the 3rd grade class. So we can see that the tape diagram for the 5th grade class is the same as the 3rd grade plus an additional 2 quarts. How much fruit punch do they have in all? Because we're trying to solve for this unknown of all of these values together. So my word problem here matches my tape diagram. But there are an endless amount of possibilities of what I could write. As long as it matches the tape diagram, it's asking for the total of all 3 of these values, and it's measuring the volume of something in gallons and quarts. Now I actually want to solve for the unknown. So I need to solve for the punch for the 3rd, 4th, and 5th grade classes all together. I know that the 3rd grade class has 6 gallons of fruit punch, 4th grade is 18 gallons, and 5th grade is 6 gallons, 2 quarts. So what would that be all together? Well, if I add all of the gallons together, 6 plus 18 plus 6, what do I get? Well, I know that 6 plus 6 is 12, and then 18 plus 12 is 30. So that is 30 gallons of fruit punch and then 2 quarts. So we have 30 gallons and 2 quarts in all. What if I wanted to write this in a single unit instead of a mixed unit? What if I wanted to know how much punch there was in quarts? What was my rule for converting from gallons to quarts? Let's look back at our conversion table. So go ahead and look back at your conversion table that you made for converting from gallons to quarts. There are 4 quarts in each gallon, which means that my rule for converting from gallons to quarts was to multiply by 4. So 30 gallons in quarts, we would need to do 30 times 4 because 30 gallons and each one is an equal group of 4 quarts. So 30 equal groups of 4 quarts. I know that 3 times 4 is 12, so 30 times 4 would be 120. 30 gallons, therefore, would be 120 quarts. So if 30 gallons is 120 quarts and we already have 2 quarts, then that means that that would be 122 quarts in all. So we could either say that in all we have 30 gallons, 2 quarts of fruit punch, or we could say we have 122 quarts of fruit punch. So in all, they have 30 gallons, 2 quarts, or 122 quarts of fruit punch. So when you go and complete your Lesson 5 problem set, you are going to be looking at problem number 2. Now look at what information you already have on the tape diagram. Look at what units it's using. And look for what you're trying to solve when you're thinking about creating your own word problem. After you write your word problem, go back and make sure that it does match your tape diagram. We're looking forward to seeing all of your creative word problems on your Lesson 5 problem set.